So what's going to happen here for unit 2 is I'm thinking on probably Wednesday or Thursday. I'll let you guys know later today. We're going to have the concept check for it. It's probably going to be Wednesday. But like I said, I'll let you know. I'll give you an update here towards the end. So we're going to try and finish on 2.2 here, which is our tolerances. So again, if you think about like a bag of Lay's chips, I like using this example here. Open image. If you think about our lovely bag here of chips, like I forget what it was, like 256 grams or something, right? This has a tolerance. We've already established that, sometimes you're gonna get a little bit more, sometimes you get a little bit less. And that's going to depend on, the equipment, the size of the chips, all this stuff. One thing though that's important to note is that they have acceptable ranges and unacceptable. They don't want to give you 500 grams in this bag, right? They don't want to give you 10 grams in the bag. There's a range at which they're like, yeah, okay, this is cool. If we give them an extra 2 grams, sometimes we don't care about that. If they give you an extra 100 grams, sometimes they care a lot about that, right? So tolerance is going to be looking at that specifically. It's going to be looking at the acceptable values outside our goal. In order to know about tolerances, we have to be able to work a little bit with fractions though. And the good news here is your calculator can do all the heavy work for you. So I'm just going to quickly kind of power through this, but again, your calculator could do this for you. You could always go in your calculator and go 1/16 plus 3/4, and it will give you the correct answer, which is great. I'm going to quickly just power through a solution for it if you didn't have a calculator and if you didn't know how to do fractions before. So how we actually do that here. The big thing with fractions is what we really need to do is we need to get the denominator. Actually, before we even go to that, so if I give you 2/3, for example. So if I give you 2/3 here, whatever's on top is what we call the denominator. Sorry, the numerator. And then whatever's on the bottom is what we call our denominator. So just so you know, like, where I'm getting that from. Denominator. So whenever you're trying to do a fraction operation, specifically with adding and subtracting them, the key thing here that you really need to do is you need to get the same denominator. AKA, you need to get the same bottom. And in order to do that, we find what's called a common factor. So let's say, for example, here, don't draw these 2 little circles here I'm doing, but if I give you a pizza here, and I cut it up into thirds, technically what I have here, right, that's a third of a fraction, right? 1/3. But what if I take that and I decide, you know what, I'm just going to cut it in half again. Well, what I have here now is 2/6, but it's the same area. So when I say common factors, is you can increase a fraction or decrease it so that you get a common factor here, so that you're able to get a number that is equal, but you can then add. You need the same denominator to add and subtract fractions. So let's do this first one here. First one is 1/16. So question A. So it's 1/16 plus 3/4. Well, I need to get the same. I need to get the same denominator, right? So I can see that. Oh, well, 4 is a factor of 16, right? I can go 4, 8, 12, 16. So why don't I just multiply this side by 4? I'd get 1 over 16 plus 3 times 4 is 12. 4 times 4, I'm trying to get the same denominator, 16. All of a sudden, that's going to give me 13 over 16, which leads us to our final step of simplifying. And your calculator can do all that heavy work for you here. In this case, it is simplified. I can't make it any better. So that's as simple as it's going to get. And again, we're just doing like a quick review here. Same thing happens for B, right? Question B is 15 over 16. Subtract 3 over 4. Just like before, I'm going to do the exact same thing. I need to get the same denominator. I see that, oh, 16 and 4. Well, a common factor here is 16, because I can go 4, 8, 12, 16. So just like before, I'm going to multiply this right side here by 4, because 4 times 4 gives me 16. And all of a sudden, I can see that I'm going to get 3 over 16. And just like before, I can't simplify this any further. That's as simple as it's going to get. So I'm just going to quickly write out question C. So for question C, it's asking us to add up 3.5 and 1/8. And obviously, you know, what makes this harder is, well, there's the big 3 here. This is what's called a mixed fraction. That's a whole number and it has a fraction in it. So one way of thinking about this is, you know, if you have 3.5 pizzas, well, I need to get rid of this 3 first off. So what am I going to do? I'm going to cut my pizzas in half, because that's what my numerator or denominator is here, right? And all of a sudden, well, how many halves do I have? I have 2, 4, 6, I have 7. So this is actually the same thing as 7 over 2 plus 1 over 8. And now I solve it the exact same way. So now I solve it the exact same way, which is, I need to get the same denominator. I need to get the smaller one to the bigger one. How can I do that? Well, 2, 4, 6, 8. I just need to times this whole thing here by 4. So 4 times 4 is going to give me 28. 2 times 4 gives me 8, which is exactly what I wanted. Plus 1 over 8. It's going to give me 29 over 8. Now, I don't want to leave that there. I want to turn this back into fractions. So what do I have to do? Well, I'm going to take this 29. I'm going to figure out how many holes there is. Again, so if I have 29, take away 8, I'm going to get 21. So there's 1. Another one, I'm going to get 13. There's 2. And I can even take a third one. 13 minus 8 is going to give me 5. So I have 3 holes. So it's 3. And then 5/8 remaining. And then the same one works for question D here, right? Only the difference is now we are subtracting. So I have 2 5/8 subtract a half. And just like before, you know, this is saying, hey, you got 2 whole pizzas and you have and you have 5/8 of a pizza here. Well, I'm just cutting these up into eighths, right? I was like going back to pizza. You can take the hard math, you can put it back to like simple concepts. Fractions can always be turned back to pizza. So all of a sudden I now have 8, 16, 21. So the whole thing here is just 21 over 8 minus that half. And I just do it the same way, right? I need to get the same bottom of my fraction, the same denominator. And I can see that, oh, if I go 2 times 4, 2 times 4, I know is going to give me 8. Now I have the same one. And I can solve my equation, right? So 21 minus 4 is going to give you 17 over 8. And you can take 2 8s out of this, right? So this is going to equal out to 2. 17 minus 16 is going to give me 1 all over 8. So again, this is not like the main thing, but we're going to need this skill a little bit. So let's go into the main part here. Like I said, this is just a little like a sample thing here. Your calculator can do all this heavy work for you as well. But it's just a nice skill to have. So let's actually go into the meat of our stuff. So we're going to go down to page 94. And so we're going to now start actually working with what tolerance is. And so essentially, well, what tolerance is tolerance is, again, we'll convert this into plain English, but the official definition is tolerance is the measurement variation allowed so that an item is acceptable for its intended purpose. That's what the fancy definition is. What is that in plain English? Well, imagine you're trying to build, I don't know, you're trying to, I don't know, like a shed or something. Like just imagine some 2x4s, right? You have some pieces of wood. Maybe you're like, hey, I need 3 foot long pieces of wood. I need these 2x4s to be 3 feet long. Well, maybe when they give it to you, it's actually 3 feet and an extra centimeter long. They would say that, oh yeah, no, that's fine. You know, so it's not going to be an exactly perfect measurement every single time. Maybe it'll be like a centimeter too short as well. They would say, hey, this is an acceptable thing. This log is so close to that 3 feet thing we're advertising that we're still going to put it for sale. So it's an accepted range as to when a product is still good. If it's outside of that range, you can't have it. Again, if you're trying to buy like a bag of chips, it says 200 grams on it. The bag itself only has 100 grams. That's not an acceptable range, right? They'd be like, no, there's way too few in here. So, so this is primarily used in manufacturing. So if you're trying to make something here, you know, this tenon, that's this little highlighted part here. This needs to be small enough to fit into this extra piece of metal here, right? It needs to be the right size. Too big, it's not going to fit. Too small, it's going to be loose. So they need it to be, you know, just big enough where it's going to fit in there. And so they have a range in which they're going to say that, hey, this is acceptable. And that's what they call that tolerance. So, so Subway, everyone knows Subway, right? So way back in the States, what they had like the $5 footlong deal, right? Most people have like seen that commercial or heard of it. So you get a 12-inch sub. And what ended up happening there in the States is they were actually 11 inches. They were a full inch off. They were shorting people. They got sued for millions of dollars and they lost. So now they have a tolerance. And basically their tolerance for a 12-inch sub is it's allowed to be 11.9 inches to 12.1 inches. So they're like, okay, if it's a little bit bigger, it's a little bit smaller, that's okay. They have a tolerance level here. So what we have here is our tolerance, right? But there's another definition here, which is what is the nominal value? The nominal value is the target value for a measurement. So in this case, in this sub case, well, what's the nominal value? The nominal value of this sub would be 12 inches, right? They're saying it's a 12-inch sub, but they're okay if it's a little bit longer or shorter. That's the difference between what nominal value is, our goal, and what the tolerance is, which is we're okay if it's a little bit off. So we have 4 different ways of showing this. So these tolerances can be written in 4 ways. And you do not need to memorize them because they should give this to you, but you are going to want to make sure that these stand out. So let's say, for example, like I'm going to pick this, if you had this sub thing here, well, what's my nominal value of my sub? We just established it's 12 inches, right? And I'm saying, hey, my sub can be plus or minus what my tolerance is. How far away? What's the range of my tolerance here? 11.9 to 12.1? Well, if I take 12.1, I subtract 11.9, I'm going to get 0.2 inches, right? So I want to take half of that. Half of this tolerance, I'm going to get 0.1. This is basically saying that, hey, what's an acceptable range for my sub? Well, it's 12 inches plus or minus an inch. It can be, plus or minus 0.1 inches. It can be 0.1 inches bigger. It can be 0.1 inches smaller. We've said anything within that range is okay. That's cool. So the target value is usually halfway between the minimum, 11.9, and the maximum, 12.1. So it's usually halfway. So that's why you've seen here, I've divided the tolerance by a half. Because the tolerance is that 0.2 figure, right? It's the range from 11.9 to 12.1. Okay, so let's try applying some of this stuff now. So we're going to go to an example here on the next page. So basically, we have someone who is making caramel candies, and they say to use a candy thermometer to monitor the temperature of the sugar mixture. Has anyone here ever made like a caramel before? The temperature determines, like, you've ever had those really soft caramels? But then you go to the store, maybe you see like a Werther's Original, like a hard candy. Maybe you've seen those really hard caramels on top of cakes that you get to like smash with a spoon. There's different types of caramel. They're soft or they're hard. And the thing that changes that is the temperature. So when you're making a caramel and you're trying to use it for a specific purpose, like I want a soft caramel, you have to heat it to a certain temperature and it can't go higher than that. So if it's not heated enough, the candies will not hold their shape. But if it's heated too much, the candies will be too firm. So this sugar needs to be heated between 245 degrees and 250 degrees. So the first thing we want to find here is, well, what's the temperature tolerance of the sugar mixture? So let's do this. So to find a tolerance, what you're going to do is it's just going to be the maximum value minus the minimum value. In this case, what's the max temperature we can have this candy at? 250 degrees, right? So the maximum value here is 250. What's the minimum value? 245. So what's that going to equal out to? 5 degrees, specifically 5 degrees Fahrenheit. I'm going to circle that because that's my final answer. So what's the temperature tolerance of the sugar mixture? It's 5 degrees. So like, is that making sense how I'm finding that? I'm literally just taking the range that it can be. So the next thing we want to look at is we want to write this acceptable temperature range. We've established that our candy needs to be within a certain temperature, and it can be a little bit too cold, it can be a little bit too hot, but only a little bit. So we want to show it all these temperature ranges, and we're going to write them in all 4 of these ways, just as an example. It's usually going to tell you which form to write it in. So we're going to show it in all different forms. So I'm actually going to go up here. I recommend you do this. I'm going to say this is 1, this is 2, this is 3, and this is 4. We're going to write it all 4 ways. And the first one I'm going to start out with, I'm just going to zoom in a second, is this one, maximum value and minimum value. So let's do B. We're going to do 1. So basically, we're just going to write the maximum value and then the minimum value right below it. Yeah. So again, what's the hottest our candy can be? 250. So maximum value is 250 degrees Fahrenheit. And then what's the coldest it can be? 245 degrees Fahrenheit, right? So all you're literally doing is just writing down those 2 values. So that's one way of showing it. So let's write it in the other form here, which is this one, this minimum value, I'll zoom in, plus the tolerance minus 0. What the heck does that mean? Let's find out. So I'm going to do number 2. Oops, number 2. So to do this, I have my tolerance and I have my minimum value. So all I'm going to do is I'm going to write my minimum value, and it was, so I'm just writing it how it's supposed to be. So plus tolerance, and then minus 0. Let me just do this. So this is how we write this first one. This is the base formula here. So what's the minimum value? What's the coldest this candy can be? 245 degrees Fahrenheit, right? But then, well, what did we establish my tolerance was? It was 5. I'm saying the reason this is a plus 5 here, I'm saying that, hey, it needs to be at least 245. That's the minimum it has to be. The coldest it can be is 245, but you can add another plus 5. Plus 5 is Fahrenheit. Notice I'm putting the units in there. But you can't take away, you can't make it any colder. You can't take away any temperature. So that's where that minus 0 comes from. Now, I'm actually going to go straight to question number 4, just because it's very similar, if you're noticing. So I'm going to skip 3 for now. So leave it a little bit of a space. Actually, no, I'll just put it right here. Don't need to leave space. I'll just go straight to question 4. So question 4 is the maximum value. And then what we do is we say it's plus 0. It can't get any warmer, but we can take away the tolerance. I know that's pretty small writing here, so I'll zoom in. So what's my maximum value? How hot can this candy get? 250 degrees, right? 250 degrees Fahrenheit. Let's make that bigger. And I'm also saying, hey, so you can have it at the maximum warmth, 250 degrees, but you cannot make it any warmer. But I can take away my tolerance, which is 5 degrees Fahrenheit, right? But you can make it colder. So that's the difference between this minimum value and this maximum value and how we show it. It's saying, hey, this is the coldest value and this is how much warmer it can get. And the other way is this is the hottest value and this is how much colder it can get. So the last little part here that we're going to deal with is, I'm just going to scroll up, is number 3 here. The nominal value plus or minus the tolerance. We did the subway example, but let's do it in this example. So question 3. So before, I've just gone with what's the minimum value, what's the maximum value, what's the tolerance. I need the nominal value now, though. How do I find the nominal value? Well, the nominal value is usually halfway between the minimum and the maximum values. So halfway between the minimum and halfway between the maximum. So it's nominal value plus or minus. Here, I'll make this a little bit smaller so it fits. So it's nominal value plus or minus 1/2 of the tolerance. Well, how do I find nominal value? Well, nominal value, NM, is just the maximum value plus the minimum value, all divided by 2, right? How do I find halfway between something? I add them up and I cut them in half. So in this specific case, my nominal value, my NM, because I've been running tight on space, the max of it is 250. The minimum of it is 245. So I'm going to add those two numbers up. I'm going to divide it by 2. 250 plus 245 is going to give me 495. I divide that by 2. I'm going to get 247.5. Again, your calculator can do that heavy lifting for you. So 247.5 degrees Fahrenheit. So now I have everything I need, right? So now I can just go to my equation here and I can just say, hey, the nominal value is 247.5 degrees Fahrenheit. And then I'm going to add and subtract. Sorry, this is plus minus. Plus minus. What's my tolerance again? It's 5 degrees, right? I'm saying, hey, it can be, I have 5 degrees of difference that the temperature can be. So what's half of 5? 2.5. So if I'm writing it properly, it's 247.5 degrees Fahrenheit plus or minus 2.5 degrees Fahrenheit. And that's it. So just to kind of like reiterate, there's 4 different ways we can show this. One is, hey, here's the maximum value, here's the minimum value. Here's how hot it is, here's how cold it is. The next one, number 2, is here's the coldest it can be, and here you can add up to 5 degrees. Number 4 is here's the hottest it can be, and you can take away up to 5 degrees. And then the third one is here's that nice Goldilocks point. Here's that one that's in the middle, right? And then you can go up a little bit and you can go down a little bit. So number 3 is all about showing you what's in the middle of it all. So what we're going to do here, so we kind of need this skill before we can keep going. So we're going to go down to question 2 here, and I want you to try this out specifically in just this form. So I'm going to give you guys a couple minutes here to write out all 3 of these questions in just this form, not all 4 like what we did up here, just a nominal value plus or minus the tolerance. And just to give you a quick reminder there, what do you need to do to find that? You need to find the tolerance. You need to find the nominal value, and then you need to rewrite the equation is how we're going to do that. So I'm going to give you guys a couple minutes for that. If you're not sure how to do it, ask. This is your time to practice the skill out. Make sure you know. I'll come around in a couple of minutes and see how we're doing, but I'm going to give you guys about, I don't know, 4 minutes or so to try out those 3 questions there. Resume recording here. So again, you find your tolerance, you find your nominal value, and you spit that into your equation here, and you get what you need to go. So we're actually going to scroll down a bit. I'll give you guys a chance later to try these out. Again, really important. If you don't know what you're doing, ask for help when you get those moments. We're going to go straight down to this one here, this 3rd example. So basically, if someone's making a new front door for their house, that you need it to fit properly in the frame, right? Even if it's a little bit off, it causes problems. So the door width needs to have a nominal value of 24 inches and a tolerance of 1/8 of an inch. And then we also want to find what the maximum and minimum values are allowed in this door. So basically, how wide can this door be, and can it still be okay? So we're saying that, hey, so first off, what's nominal value mean again? Is that the highest, the lowest, or the middle? It's the middle, right? So I'm saying that, hey, the nominal value is 24 inches. What that's saying is here is that if I have a door, the middle value here is this 24 inches. You don't have to draw this part here. I'm just kind of doing it as an example. I'm saying that, hey, it has a minimum value here of, sorry, it has a nominal value. The middle value, the acceptable range, and that's right in the middle, is 24 inches wide. But I'm also saying that this whole gap here has a tolerance of 1/8 of an inch. So if this whole thing is 1/8 of an inch, how can I find just this part? Well, this is half of that, right? So can't I just take half of the tolerance? I'm saying the tolerance is half of an 1/8 of an inch, sorry. But if I want to find the maximum minimum values, well, I need to move half of that distance away and up from it. So what I'm going to do is I'm going to take 1/8 of an inch, and I'm going to divide the whole thing by 2. So what's half of 1/8 of an inch? It's going to give me a 1/16 of an inch. So what I'm saying, so basically what this basically means is that, hey, our tolerance is 1/8, or I can go a 1/16 of an inch smaller or wider, is really what that's coming down to. So how can I find these two values then? Well, can't I just take this 24? If I want to find the widest, I can take this 24, this middle value, and add on that 1/16, right? So my maximum is the nominal value. I'm going to put NM. We'll get used to that. So my maximum is NM plus 1/2 of the tolerance, right? That's the fancy way of saying is, hey, I said the door needs to, it's, we're aiming for 24 inches, but it's okay if it's 1/16 of an inch off. So 24 inches plus 1/16 of an inch is going to give me 24 and 1/16. So, well, how do I find the minimum value then, right? Well, isn't this going to be the same thing? Isn't this minimum's just going to be what's my nominal value, what's my middle value, minus my tolerance, or half of my tolerance. Right? So I just know that, hey, it's 24 inches minus half of my tolerance is 1/16 inches, right? That's what we already established. So 24 inches minus 1/16, it's going to be 23 and 15/16 of an inch. And again, your calculator could do that heavy lifting for you. You can just plug this in your calculator. If you're not sure, it'll give that to you. So what we're going to do here, we have one more example we're gonna do. I'm gonna give you guys a little bit of a break from just like taking notes. So instead, I'm gonna use the opportunity to practice this stuff. So you'll be able to work on questions 3, 4, 5, 6. I think there was a 7th. Yeah, 7. Yeah, so questions 3 to 7. I'll give you guys till about the break for that. Again, ask for help if you're not sure. I'll just write this down here. I'll just write this over here. So basically, questions 3 to 7. We'll have our break at 2 o'clock. And then at 2:15, we'll go through our last example. And remember, there is that assignment that was given out on Friday. If you do finish this, you can start working on that. There's one more thing we have to do, but you should be, at this point, able to really handle anything in that assignment. So I'll give you half an hour here or to work on this stuff. Go for your break. At 2:15 sharp, we will continue onwards. Okay, so we'll do one more example here. So this one's going to just be, we're going to go straight down to page 99 here. Again, if you're not sure on stuff, ask for help afterwards when we're done this example. With example 4, what page is this again? 99. Okay, so longer word question here. So it's really important to read it carefully, right? It's a very important skill, especially for this class. So we have someone who's building a brick wall as a fence for his client's yards. His clients have asked the wall be 2.40 meters tall with a tolerance of 10 centimeters. So as not to obstruct the view from their patio so that their dog will not be able to jump over the fence. So we want to know is what is the range of acceptable heights? So what's the minimum, what's the maximum value? And then we're also given some additional information from question B, which we'll talk about shortly. Now, one thing I really want to mention here is we have 2.40 meters and 10 centimeters. They are different units. I'm just going to quickly write down what the meters would be in centimeters and what the centimeters would be in meters. It's helpful to have the same units, right? And that was that thing we did all the way at the start on Thursday. So let's do A here. So we have they've asked for the wall to be 2.40 meters, right? That's their goal in this case. But they've said that, hey, you can have a tolerance. It can be a little bit shorter. It can be a little bit taller than that. So that 240 is actually, 2.40 meters is actually our nominal value. And so just like before, if I have 2.40 as my nominal value, right? That's that middle part. It can have a tolerance of 10. I'm saying that it can be a little bit shorter. It can be a little bit bigger, but all of it can only be 10 centimeters. So if that's the case, if the whole of it's 10 centimeters, well, half of it is just going to be 5 centimeters, right? So it can be 5 centimeters shorter or 5 centimeters taller. So I'm going to put these in the same units. I'm going to go to centimeters. Let's try and avoid the 0 decimals. Let's avoid that. So I'm going to say, what's the minimum value it can be? Well, I know that they want 240 centimeters, and I know that it can be 5 centimeters shorter. So the minimum value is 235 centimeters, right? And the maximum value, just the same thing. Well, I know it can also be 5 centimeters bigger. So 245 centimeters. So I now have my ranges here. So the wall has to be between 235 centimeters to 245 centimeters. So that's question A done, right? I'm just gonna write that over here. That's question A. That's done. My final answer, I like circling it, is it needs to be between 235 and 245 centimeters. Done. Now we're going to look at question B. So I'll scroll up. I'm just going to read question B out here. So if each brick has a height of 7.5 centimeters plus or minus 0.25 centimeters, because remember, everything has a very small tolerance. Not all bricks are going to be the exact same height. So if every brick has a height of 7.5 centimeters plus or minus 0.25 centimeters, and the mortar must be between 0.7 centimeters and 1 centimeter thick between each row, well, how many rows of bricks and mortar is it going to take? This is a complicated question. This is a difficult question. So like, I'm just going to draw, again, they're looking, well, okay, how many bricks and, mortar can you have until you get up to that 240 centimeters, right? That's what their goal is here. We're trying to figure that out. Now, you could go one by one, just like what I'm doing here, and try and figure that out, but that's going to take a while. Let's try and think of a mathy way to be able to do this. So what I'm going to do for question B is I'm going to find the max and min values of the bricks. Let's start with that. Now the maximum, how big does it say the brick is? I'm just going to scroll up a second. So the bricks, 7.5 plus or minus 0.25. So what's my maximum? Well, it's 7.5 centimeters plus 0.25, 7.75 centimeters. And the minimum is going to be that. It tells us it's 7.5 centimeters minus 0.25 centimeters. 7.25 centimeters. So this is the maximum value of our brick. So what I've done is, if I'm looking, I'll actually make that bigger. And sure, let's do that. So if that red line there, if those are the bricks, cool, we can figure out how long it is. Why don't we figure out how much a brick and a mortar is now? Let's figure out how big those are. So we've done the bricks. Let's also do the mortar. Let's do the min and max values of a brick and one layer of the mortar. Right? Because that makes sense. It's a brick and then mortar, and then a brick and then mortar, and then a brick and then mortar. So why don't we just combine this all together into one? So here's what I know. The maximum, what's my maximum brick value? Well, I just calculated, right? 7.75 centimeters. And then it's saying the mortar, I'll come back down. I'm just going to scroll up 1 second. The mortar must be between 0.75 and 1 centimeter thick. So I'm just going to add up what's the, if I put the most mortar and the biggest brick together, the biggest it's going to get is 8.75 centimeters, right? If I take the smallest brick and the least amount of mortar, and I put that together, the smallest combination I can get is 8 centimeters, right? Okay, so I know how big the wall needs to be, right? I have my big wall here, and now I know if I take the smallest combination, the minimum amounts, I could just go up 8 centimeters, 8 centimeters, 8 centimeters, 8 centimeters. I could just go all the way up until I get to that 2.4, right? The other way around is I could also go up 8.75, 8.75, 8.75, 8.75. I could do that all the way up until I get that. Instead of counting one by one, though, why don't I just divide it? So I now know the maximum and the minimum, right? So if I want to find the max and min layers, well, I know I need to have 240 centimeters, right? Let's find the maximum. I know I have 240 centimeters of total height to work with, right? So I'm finding the maximum, sorry, not 240, not 240 centimeters, 245 centimeters. I have 245 centimeters of wall I could build because there's that tolerance. So why don't I take the tallest it could possibly be and divide that by the shortest layers? Because that's going to tell me the biggest possible things that could happen. So I know that if I have 245 centimeters and I have 8 centimeters, if I have 8 centimeters of the smallest layer, well, I can just punch my calculator. It's going to give me a correct answer here. So it's going to give me 245 divided by 8, 30.65 layers. You can't have half of a layer, right? But I can't go over that 245. That's outside my tolerance. So the answer is 30 layers. That's the most amount of layers I have. If I build the tallest wall I'm allowed to with the smallest stacks, that's it. But what about if I want to use the shortest wall? Because I'm allowed to build it that short, right? So what if I want to use the shortest wall and I want to divide that by the biggest amount of layers I can use? So 235 divided by 8.75. So if I do that, I can see that, oh, well, that's going to be 26.85 layers. Let's do, what happens if I go to 27? Sorry, what happens if I go to 26? I'm shorter than what I need, right? So before I had to round down. In this case, though, I need to round up. I need to say it's going to be 27 layers because 26 is too short. It needs to be at least 26.85. So I'm going to say it's going to be 27 layers. Okay, so remember, the question, though, however, I'll come back to this. The question asked me, how many rows of bricks and mortar will it take to build the wall? Well, we have two different numbers here. But the answer depends, right? The correct answer here is the wall will have between 27 to 30 layers. It could be anywhere in between that. This is still an acceptable answer, right? It's a range. It just depends on how thick is the mortar, how thick is the brick, how high or short is the wall. So this is, the math itself is not hard, but the hard part here, right, is setting this problem up. And I can promise you, like on your final exam, you will not be given something like of this difficulty. This is a very difficult problem for this unit. You will not be given something as difficult as this. Okay. So what's going to happen now, and this is for today and tomorrow, you can finish the entire booklet, all of it. That's it. There's two chapters. That's it. You can finish the entire booklet. You can finish the unit 2 assignment. And we're going to have the concept check on Wednesday. That's the 7th. And specifically, it's gonna be right when you guys come in on the 7th, okay? So it's gonna be 12:30. Boom, here's a concept check. So I'm sorry about that. Because then we're gonna carry on. We're gonna start with our next unit 3 then. So today and tomorrow is your time to do these 3 things here. Again, if you are not sure what's happening, please ask for help. And should you somehow finish these 2 things, you could work on chapter 2 in the textbook, and that's what's on the LMS. That's on the introduction on the LMS. It says textbook, not workbook, textbook.